Hello everyone, and welcome back to the show. It's your host, ichino-ani here. Today is June 30th, a bright and sunny Monday, and you know what that means. It's time to dig into the archive and find a super interesting paper for us to learn about. We're looking at a really neat one from the world of machine learning. The title is Maximal Matching Matters, Preventing Representation Collapse for Robust Model Retrieval. That's a mouthful. It's a brand new paper from just a few days ago. The corals.abs/2506.21538. It just came out. So, what problem were these smart researchers at Virginia Tech trying to solve? Well, let's think about it like this. Imagine you type into a search engine the description of a picture you want to find. That's called cross-modal retrieval, going from one mode like text to another, like an image. The tricky part is, one picture can be described in so many ways. The paper gives a great example. A picture of a person surfing with a kite could be described as a person doing an activity in the water on the beach. Though the guy is flying the kite high in the air as he surfs. Give me a sand picture. Most older eyes try to solve this by stitching all the information from a picture, or all the information from a sentence, into just one single idea, or what they call a single vector. Well, that's like trying to describe your entire summer vacation in one word, and lose all the fun details. So a newer idea is to use a whole set of ideas or embeddings for each picture and text. This is much better. You can have one idea for the person, one for the kite, and one for the water. But there is another problem. It's called representation collapse. It's like the AI gets a bit lazy, even though you ask it for a set of different ideas. It just ends up giving you the same idea over and over again. All the different ideas just collapse into one single point, so you're back where you started. This is where today's paper, MaxMatch, comes to the rescue. It has a super clever way to stop this from happening. It uses something called Maximal Pair Assignment Similarity. Think of it like this. You have a set of puzzle pieces that describe an image, and another set of puzzle pieces that describe the text. Instead of just trying to force them all together, MaxMatch acts like a perfect matchmaker. It carefully finds the best blend-part partner for each piece. The kite piece from the image gets matched with the kite piece from the text. The water piece gets matched with the water piece. This way, every single piece has a job, and they're encouraged to stay different and diverse. They'll also add two special rules to make it even better. One rule basically says, hey, all you little ideas, you need to be different from the main big idea. And the second rule says you all need to be different from each other too. Isn't that smart? So, how could we use this in our daily lives? I can think of a few ways. First, imagine a much better image search. You could search for something very specific like a fluffy black cat sitting on top of a silver laptop, and because MaxMatch knows how to match all those different parts, it could find the exact picture you're thinking of. Second, think about recommendation systems on shopping websites. Let's say you're looking at a picture of someone skateboarding. The AI wouldn't just recommend more clothes. It could understand the different objects and actions. So it might say, oh, you like that white shirt? Or some other cool skateboards. It can give you much more specific and helpful suggestions. And third, and I think this is really wonderful, this could be a huge help for people who are visually impaired. And the AI with this technology could describe a picture with amazing detail. Instead of just saying a baseball game, it could say, a player in an orange jersey is swinging a bat, while another player reaches to catch the ball. It can break down the scene into meaningful parts, making the world more accessible. Compared to other technologies, MaxMatch minds because it solves a tricky set collapse problem. Other methods that use sets of ideas, like one called setive, often end up with all the ideas becoming the same. But MaxMatch, with its clever matchmaking, keeps the ideas diverse and useful. And the best part is, it does this without needing huge amounts of extra data, or models that are super slow. It's both smart and efficient. So this paper shows us a fantastic new way to help computers understand the rich and diverse connections between what we see and what we say. It's a big step forward. That's all the time we have for today, everyone. Thanks for tuning in and keep on learning. Bye-bye for now.